Hi, my name's Trevor Bagnall and welcome to this YouTube video where I'm going to make a set of LED flexible lights, the idea of which I got from Matt from DIY Perks. Now Matt is a YouTuber from over in the UK. He's got lots of different DIY projects on his channel. It's well worth a check and I'll put a link up there in the corner. So this is my tribute video to Matt and DIY Perks for the idea to make these LED light panels. A while back I bought some Aperture Amaran 672W LED light panels when I got back into shooting video. These are nice light panels that are very bright and have remote control capability, but they're only a single color temperature model only. I only ever had 2 of these panels, so getting a full complement of key, hair, and fill lights meant I was always one light panel short. And of course, ever since I dropped one of them down in the oily bilge of my boat, I was using it as a work light at the time. You can see it doesn't work at all, and I can get it to work if I put it on batteries, and the dial looks like it's doing something, but there's actually no difference in the output of the light when I use the dial, and half of the lights aren't actually lighting up on this LED panel. You'll be able to see that in the video because it's so bright, but only half of the LEDs are lighting up on that one. To replace this panel, I'd be looking at over $330 Canadian plus taxes plus shipping to purchase a replacement, or double that of course to get to having 3 lights again. Instead, after watching Matt's video on his DIY Perks channel, I decided I could build 2 of these panels for cheaper than buying one single color temperature light to replace the one I messed up. For $200 Canadian total investment, I now have 2 dual color temperature light panels and 3 lights in total.
So sit back and enjoy.
I had some vinyl material left over from a flight simulator cockpit build that I built a few years ago, so that became my backing material for this build. The lights themselves are 2 5-meter rolls of 95 plus CRI rated lights in 5500 to 6000 kelvins and 4000 to 4500 kelvins, which puts them in the bright daylight and tungsten light ranges. 2 pulse width modulators from Amazon and a 19.5 volt power computer supply round out the major materials for this build. Next, I cut all the LED lights. I cut off the end with the power lead at the first cut line on the strip, and then cut 16 pieces that were approximately 30 centimeters long each, cutting only at the marked cut locations on the strip. Each 5-meter strip allows for 16 pieces 30 centimeters long, with a short 3 LED strip with power lead still attached, and a 9 LED strip again with power lead still attached. And I'll recycle these into another project, maybe a homemade LED light or a bar or a flashlight. I put all the strips in the middle of a heavy book to help take out some of the curl out of the strips. Then the process is repeated for the other color temperature LEDs. Next, I measured and cut out the backing material, making sure I was very careful to get the edges cut exactly at 90 degrees to each other, as it just makes the rest of the job much easier. For this build, I went slightly larger than the measurements that Matt from DIY Perks showed in his video. For the first panel that I made, I had a hard time wrapping the 2 sides of the first LED panel where all the wiring was, and still making it neat enough. So I allowed for some extra material on the edges to make that part easier. I went an extra 2 centimeters wider on the finished border, so an extra 4 centimeters of material per edge as it is folded over when complete. I marked out the area where the LED strips were to be attached to. I made a mistake on the measurement and had to go back and mark a second line at the right location. Before I glued down the strips, I took one last pass at getting the curl out of the strips, still keeping the 2 different color temperature strips in separate piles. To glue down the strips, I used a fabric mending glue called So No More. It was very effective for gluing down the strips. I applied the glue over a wide area and spread it out using a 1-inch putty knife to get a good consistent layer of glue. Not a lot of glue is required, and I found that extra glue would not help here and would only take longer to dry. I wouldn't advise coating the whole area with the glue at once, as it dries to tacky consistency fairly quickly. Then the strips were laid down in alternating rows, taking care to get the strips aligned and fitting tightly together, but yet not overlapping with each other. Because the glue was laid out in only a thin layer, the strips adhered well right off the get-go. I would advise keeping a small bowl of water nearby when gluing down the strips to keep your fingers clean as you lay down the strips. Keep alternating the rows of LED strips, and of course keeping the wiring on the strips always in the same orientation. This makes wiring up the strips and keeping the proper polarity alignment, and that'll make wiring up much easier later on. Fortunately, the cut locations on the LED strips were of a slightly different design for each color temperature strip. This made it easier to keep track of which strip to lay down next and not get two strips of the same color temperature right beside each other. Once all the strips are laid down, I piled all my old university books on top of the strips to keep them pressed down overnight whilst the glue dried. I find it a bit ironic looking back on this that I used the physics books to be the item upon which gravity was acting for this stage of the LED panel build. I think there might have even been an electrical circuit book in that pile as well. The strips were left overnight to dry. The next morning I removed the books and found small areas where the strips were lifted ever so slightly, so those were tamped back down and the whole thing tested by rolling it up to see if any of the strips would come loose, but none did. I prepped all the strips for soldering by applying a dab of solder to each of the exposed copper wiring pads, of course only applying solder to every alternating LED strip, as only every second LED strip gets wired together on the same side of the panel, thus all the same color temperature strips wired up on one side and all the other color temperature strips get wired up on the other side of the panel. Next comes the wiring of the strips. The wiring that I was using was a 22 gauge solid core wire instead of stranded wire, but only because it was what I had available. I didn't bother with different colors for positive and negative wires at this point, but it would have made keeping track of the wires a little bit easier. Following the instructions from the DIY Perks video, I cut each piece with 9 exposed joints on each strand, and then folded the piece over like a paper fan to prepare it for soldering to the strips. I made a total of 8 identical wires, and then soldered them all in place, keeping the polarity straight, and then when all the sections were wired up according to the plans, crossed over the positive lead from one half of the strips to the negative lead of the other half of the strips, thus forming a group of 8 LED strips in parallel, which were then wired in series to the next group of 8 strips in parallel. This takes the 19 volt power source down to a 9.5 volt drop across each group of LEDs. Once all the wiring was done, it was time to form the corner pockets for mounting the panels later on. Starting at the fold lines, 3 cm slits were cut at each corner, and then strips of vinyl cut and glued in place on the corners to form the pockets. The trick with the crazy glue to stick things down whilst the fabric glue dries works wonderfully. Just to be safe, I used a fold back clip to clamp the pieces together for a few hours, while I moved on to the controls wiring. I bridged wiring across the 2 power input terminals on the pulse width modulators so that only one set of power leads to the first pulse width modulator would feed power to both. At this point, before the edges of the panels were folded over and glued down, it's a good time to check that everything is in working order, so I temporarily wired up the controls and fired up the lights. To give the panel the rigidity it needs, a heavy wire should be run around the edge of the panel. The wire I had on hand was a little too flimsy for my liking, so I doubled up the wire, clamped one end in a vise and the other end into the chuck of my cordless drill, and then I twisted the 2 wires together tightly, which made for a heavier twisted pair wire. I also like the idea of having a twisted pair wire like this, as I think it will fatigue less over time than a solid wire being bent back and forth. The leads that go back to the controller were taped to the wire using vinyl electrical tape, and then the silicone applied to the edges of the fabric. The fabric was folded over and then held in place whilst the silicone dried using masking tape and fold-back clips. For the controller box, I took some stiff cardboard and made a pattern for a box, cut it out, removed a few bits of the material at the fold lines to allow it to fold better, and then mounted the pulse width modulators to the box, folded the box up around the controllers and wiring, and then wrapped the box in electrical tape to finish off the assembly. Lastly, for the panel mounts, I had some light aluminum flashing coil that I used when I built my house. It was too light when I cut it into a single layer strip, and the LED panel kept falling off the mounts as they were flexing way too much. To compensate for this, I cut my strips 5 centimeters wide rather than the 3 centimeter strips that the plans call for. I used the extra centimeter per side to fold the aluminum strip back onto itself, which made the strip a lot stiffer and more than adequate to hold the panels firmly in place. The 2 supports were aligned with each other and taped together, and a 9/32 hole drilled through the pair of the supports. The ends of the supports were trimmed to a point and the ends sanded down to remove the sharp edges using a Dremel tool with a flapper sanding wheel attachment. And then the supports attached to the panel, and the panel mounted onto the light stand using a 9-inch Magic Arm clamp. Okay folks, well that's just about it for this video, so thanks for watching. And before we go though, I just wanted to mention, I didn't think it would be right to make a video about LED flexible lights for video without actually shooting the video using the flexible lights that I made. So hope you enjoyed this. If you like this, give us a thumbs up and subscribe to the channel for more content. And until then, my name's Trevor and we'll see you in the next one. Thanks, bye-bye. Completely crazy, but oh well. I'm not a fashion model.